Hey guys, today we're going to do 2.5 using linear models. So you will be able to write linear equations that model real-world data, and you will be able to make predictions from linear models. Our essential understanding is sometimes it is possible to model data from a real-world situation with a linear equation. You can then use the equation to draw conclusions about the situation. I'm also going to be in the corner today because I'm going to be showing you some things on the graphing calculator. So I will be in and out of the screen to show you demonstrations. So a scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. We could use a scatter plot to determine the strength of a relationship or a correlation between data sets. So the closer the data points fall along a line, it either means the stronger relationship and the stronger the positive or negative correlation. So between the two variables, we have a strong negative correlation here in the first graph, because our data points are close together and they are all going in a negative direction. We have a weak negative correlation because we're still going toward that negative way, but they're kind of spread out, so our data points aren't too close together. Then we have no correlation if we have points all over our coordinate plane. A weak positive would be our data points are going upward, but they're not too close together. And then a strong positive correlation would be, once again, we are moving positive, but our data points are close together. Problem 1, using a scatter plot. The table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. We are going to make a scatter plot, and then we are going to describe the correlation. So we have temperature and electricity bill. We have to think about which is our independent variable, and we're going to go with temperature is not affected by the electricity bill, but rather the electricity bill is affected by the temperature. So our independent variable would be our temperature, and our dependent variable will be our electric bill. So I created a coordinate plane with the values on my x and y axis. My y axis is electricity bill. And my x-axis is temperature. So now I'm going to take each coordinate point. I'm going to take 61, 150. I'm going to graph 80, 58, 139. And I'm going to keep graphing, so I'm going to pause the video and finish graphing. You guys do the same. So, as we can see on our scatter plot, as our temperature increases, the electricity cost also increases. The points are relatively tight in this area, and so there is a strong positive correlation between temperature and electricity cost. Problem 2, writing the equation of a trend line. So, first, what is a trend line? A trend line is a line that approximates the relationship between the variables or data sets in a scatter plot. So we can use a trend line to make predictions of data, and we're going to use 2 points from our data set that are on this line to find the slope, so then we could write the equation of the line. So we are going to write the equation of a trend line. The table shows the median home prices in Florida. And what is the equation of a trend line that models the relationship between time and home prices? And then we're going to use their equation to predict the median home price in 2020. So we have our graph here. Set up for us. X is our number of years. Y is our median price. And we're going to graph all of our data points. So X is the number of years since 1940 because we need to have a starting point. So 1940 is going to be year 0. 1950 would be 10. 1960 would be 20. And then the median price. So first 1940 to 23,100. Then 1950, 40,100. 1960, 58,000. 100. 1970, which is 30 years from 1940, is 57,600. 1980, 89,300. 1990 is 98,500. And 2,000 is 105,500. Now we're going to sketch a trend line. So when we're sketching this trend line, we want to make it as close as we can to the points given. So I want it to be right, so that's pretty close. Now we're going to pick 2 points on our line. So on this line, I'm going to pick, I'm going to pick 10, 40,000, and yeah, that's a little bit better. 10, 40,000, and 55, 110,000. So those are my 2 coordinates. I'm then going to use my slope formula, which is y2 minus y1 over x2 minus x1, which is equal to 110,000 minus 40,000 over 55 minus 10. would be my slope. So if that's my slope and I have a y-intercept of 30,000, I could then write my line of best fit as y is equal to 14,000 over 9x plus 30,000. In order to find the median price in 2020, how many years is 2020 from 1940? That would be 80 years. So I'm going to plug in 80 for x. So y would be equal to, or the median price of homes in 2020 would be $154,444. Of course, this is an estimate. That's all for today.